Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Know-How is brought to you by CashFly at CACHEFLY.com.
This episode of Know-How is brought to you by Harry's. For guys who want a great shave experience for a fraction of what you're paying now, go to harrys.com. Get $5 off your first purchase by entering the code KNOWHOW when you check out. And by lynda.com. Lynda.com is an easy and affordable way to help you learn. Instantly stream thousands of courses created by experts on business, software, web development, graphic design, and more. For a free trial, visit lynda.com/knowhow. That's LYNDA.com/knowhow. On this episode of Know-How, we're going deep into feedback. Aaron Newcomb is dropping by to give us some more Linux tips, and then we're going to teach you the secrets of flight. Welcome to Know-How. It's the Twitch show where we build, bend, break, and upgrade. I'm Father Robert Balliser.
And I'm Brian Burnett.
For the next, 45 minutes? 30. It's a long episode. For the next 50 minutes, we're going to be letting you into some of the projects that we've been working on over the last few weeks so that you can go home and geek out on your own time.
Right. And so the article this week that you picked up on was a little computer kit?
Yeah, it was a cool idea. It was a Kickstarter. They tried to get 100,000. They ended up getting 1.5 million, which was awesome.
Yeah, that's
the
lot
idea,
more than they asked for.
Yeah, way more than they asked for. It was the Kano or the Kano or the I think I'm going to call it the Kano.
Kano?
Yeah,
Sure.
Kano.
K-A-N-O.
Yeah, the idea is it's a computer that you make yourself. It's a great idea.
All right, I'm up for that.
Right, so you know that you get this little kit, and you build it with your kids. They learn about computers, and then they learn about programming because the Kano operating system was designed to teach.
Oh, okay.
It's a nice idea.
I mean, it looks like a very nice package, and everything's put together well. And I mean, the graphics on the website are definitely well put together.
Yeah, and I do not want to crap on anyone's idea. I actually think this is a good idea because if you can get someone who wouldn't otherwise get into building a computer,
right,
this is great.
Right.
I have one issue, Brian.
What is that?
This is just a Raspberry Pi.
Yes, this is a Raspberry Pi with a few accessories and then with a price tag of $150.
$150, right. Yeah. So it's got a Raspberry just like this. This is just a Raspberry Pi. It's a single board computer.
We're talking like $35.
$40 for this. It's got the memory card with the Kano operating system. That's like $5, the one that they chose.
You can't just download the operating system? Or
I mean, you could. It's just a Linux distro that they've customized with their graphics and their branding. It's got a case, which might run you another $5. It's got a wireless keyboard and mouse, which is another $10 or so.
Right.
It's got a Wi-Fi dongle, which you can get for $4.
Yep.
So, you know, all in all, it's like maybe $70, $75 worth of parts.
There's quite a bit of a profit margin there.
Yeah.
For packaging, I guess.
Again, you know, the fact that they are encouraging people to build their first computer, that's cool, but it's it's a really underpowered computer.
Yeah, definitely. I mean, I love the Raspberry Pi, and I've had a lot of fun projects with it, but I mean, it's not going to be your one PC that you do for everything.
Yeah.
I guess it could be your first PC if you're a kid building it, which is who they're trying to target. But it's just so packaged and put together.
That's the problem I have with it. And again, I still think it's a good idea. I still think the people who bought it will get something that's fun. We love playing with the Raspberry Pi. But they bill it as this, your kid will build a computer.
Right.
You don't build the Raspberry Pi.
You're attaching peripherals to a board.
Power, networking, HDMI. That's it. And everything else is preloaded. So, you know, building, it's building in the sense that you build your game console.
Right.
By plugging it in.
But so then the next step that you did was you pieced together some parts for around the same price, but different specs here. You've got a different board and everything.
I wanted to know if I'm going to poo-poo this idea and say that this is so expensive.
What could you do?
Could I do something for $150? This costs $150. What could you actually build? If you really wanted your kid to have the experience of building a computer, what would a complete kit cost? So I did a few things. So if you go to the overhead, I started with this. This is a an MSI motherboard. This is an AM1. This thing will run you about 30 bucks. Then you've got a AMD Sempron CPU. This one's about $31 or so. So you're looking at like $61 for the motherboard and CPU. This is actually pretty capable. This will run Windows decently. It will do all the browsing, and it's actually expandable, which is kind of nice. For the memory, I was looking at some Corsair sticks that I found. You can get a set of 2 of these, so 2 gigabytes for about 20 bucks.
Oh yeah, definitely.
You're right, and that's not a stretch. Of course, I couldn't get the SSDs, but I was able to get a 500 gigabyte Western Digital Scorpio, a 2.5-inch drive, for about $21.
Yeah, that's like when you'd find in a laptop, right? About 5,600 RPM or something.
Exactly, and then adding the keyboard and the mouse and a case with a power supply adds another $37 to $40. So all in all, and we'll put the list on in the show notes. All in all, the parts that I bought cost exactly $150.
Right.
And that gives you a computer that you actually have to build. It gives you a hard drive and optical drive so you can install a Linux distro. It gives you a much more capable machine, and your kid actually will know what the parts are when he's done, or he or she is done.
The thing I like about going the route that you did is it gives you a little bit more flexibility with some of the parts that you got. And I don't know about you. Well, obviously I do know about you actually. You have a ton of stuff laying around.
Yes.
But I mean, I've got an extra keyboard laying around. I have that stuff. So really buying the kit, it's not for me because just because everything looks pretty together doesn't really mean that I want to spend extra money for it.
Right. And like you said, as you start building this, you're going to start saying, wait a minute, I can do 2 gigabytes for $20, or I could do 4 gigabytes for $30. I could spend an extra $6 on the CPU and get one that's 30% faster. I could maybe go with an SSD and make this a screaming machine for $30, $40 more. So it's infinitely upgradable, but then you start getting into the range where for about $220 you could buy a pre-bundled Dell machine with Windows and everything. So yeah, what you're looking for is that educational machine. I do believe the Kano, whatever we're calling that thing, does have merit.
Yeah, obviously it's popular.
It's popular.
It got way beyond its Kickstarter, what they set for it. But it's for me, it's not for me.
It's not for you. And maybe if you've got a nephew, a niece, a son, a daughter, someone who you think might want to learn about this.
And then just give it to them and see where they go with it.
Yeah.
So again, this would definitely be a project that you would have to help someone who doesn't know much about computers with.
Right.
You would have to be the one that gets the parts together and everything.
But at the end, you actually have built a computer.
Yes, yeah.
Truly, I mean, versus plugged it in, made sure that the power light turned on. They'll probably have to troubleshoot a little bit because something won't work right the first time. But the cost is low enough where you could let them make a couple of mistakes and say, all right, well, now do you know how a computer works? Even if you never build another computer, it's still a good thing to understand all the parts.
Definitely.
Now, when we come back, we want to show you a little bit of feedback. We've had some really good questions in our Google Plus community. I mean, it's been an active community the last few weeks.
Yeah, it's crazy. It's really exciting to see all the projects and things that people do in there too.
Yeah, exactly. And that's what we want to show off. We want to show off some of the things that people have asked and some of the projects that people have been working on. But before that, we want to thank the first sponsor of Know How, and it's Harry's. Now, you need a good shave. We know that you need a good shave, so you should be looking for a premium product. And that's exactly what you get with Harry's. Now, let's admit, shaving isn't fun. Sometimes we cut or scrape ourselves with dull blades, and razors are expensive. They can run about $4, actually $5 or $6 a blade. And, if you've ever done that that sad, lonely walk into the supermarket aisle, and the blades are locked behind a case because people
and then you have
to
go find someone to get them out.
Well, why do that to yourself? Why not just get yourself a great shave from Harry's? It's the company that's fixing all this shaving stuff. They make the razors in their own factory in Germany. They engineer them for sharpness and high performance, and they ship them for free to your front door. And because they make and ship their own blades, Harry is a more efficient company, which means that they can give us their factory direct pricing, and they guarantee you satisfaction. In each kit, you get a razor with a handle that looks and feels great. Actually, I love mine. 3 razor blades and a foaming shave gel, which is just so smooth, and it's got that nice scent to it.
Smells good, yeah.
It does smell good. Now, I have been using Harry's for a while. Ever since they sent me my premium shave kit, this thing has been living at my home, and it's what I shave with. And you know how shaving becomes a ritual after a while?
It does. It becomes an experience.
Yeah, and you know, if you're going to have that experience, why not use something that's nice, that looks good, that feels good, that just has the right weight, and that's definitely Harry's. Now, what we want you to do is we want you to see if maybe Harry's is what you need, what you want for your shaving ritual.
I don't shave often, but now when I do, I now use the kit. And it's nice, but I allot myself like an hour. Like, I'm going to take a shower, and then I'm going to shave.
And folks, let me tell you right now, if we get enough of you going to Harry's, we'll make Brian shave on the set.
No.
It's a good idea, right?
All right, yeah, Jeff was bugging me to do it.
Oh, how about this? How about this? We'll make you shave half your beard on the set.
Oh, yeah.
Just right down the middle.
That would be a good look. Yeah, then
it's
you
a good
can see
look.
the side by side. Yeah.
So there you have it, folks. Go to Harry's, and Brian will shave half of his face.
All right. Maybe just one eyebrow.
Now, if you are convinced that you want to try Harry's in your personal grooming technique and have it in your kit, why not try out our special offer? Go to harrys.com and get $5 off your first purchase with the code KNOWHOW. That's HARRYS.com and enter the code KNOWHOW at checkout. And we thank Harry's for their support of Know-How.
Burke suggests I shave one arm. That way, I'll take a couple of razors, I
like what Kilohertz iPad is saying. He's shave your head.
Oh, I don't know about that.
The flowing locks. You don't want to go in that
Just
look?
Gone, yeah.
Yeah. We'll see. We'll see. We'll try something. All right, now let's get into the feedback. Because like I said, we've had
Google Plus stuff.
Some decent questions in our Google Plus community and sent to us. The first one was actually sent to us by a user by the name of Jani H. Maybe Yanni? Probably Yanni H.
From Amsterdam?
From Amsterdam. And Alex, if you go ahead and roll that. He wrote that in several episodes, you have talked about tapping networks in order to slurp packets without users knowing about it. I know you've shown us several very expensive devices that can tap copper lines without changing the characteristics of the electrical signals flowing through a network. But what about new networks? Most new networks are switching to fiber. Is there anything that they can do, any way they can do something similar on those new networks? Well, Yanni, this is a very good question.
There has to be something.
There definitely is something. Now, what he's talking about are the devices like this. This is a net optics tap that we've been playing with on a couple of episodes. If you go to the overhead, it's an aggregating tap. So it allows us to have in and out, so it's the pass-through, and then we can take the receiving traffic and the sending traffic. And we can either take them singly or we can aggregate them together so that I can get them both on my computer in one stream.
Okay.
Now, very cool, but that's how it's been working for copper. Copper is usually easier to tap just because I'm dealing with electrical impulses. We know really well how the characteristics of electrical impulses work.
It's a lot more common.
It's a lot more common, and there are a lot more devices that are designed to work with copper.
Right.
Like I can use a hub as a cheap tap.
Right.
Or I can make myself a really crazy, like $1.50 cheap tap using 2 RJ45 jacks and some Category 5 cable.
Okay.
It will only run at 100 megabits per second, but still it would be a tap. He has a good question, which is, well, how do we do that with fiber?
I'm wondering, so this must be like a home network with fiber?
Well, it could be. I mean, some of the newer home networks come with fiber, or it could be one of those networks that, maybe you have an enterprise class network, maybe you've got fiber to the home, or maybe you're planning some nefarious stuff.
Or maybe you're just an enterprise guy and you just want to know.
Maybe you're just an enterprise geek and you want to know. And actually the answer is yes. If you go to my overhead again, this is actually a fiber tap. It looks a lot smaller because it's actually not that complicated. And just like the copper tap here, I've got a way to have an input and an output. So that, the pair that comes in, the pair goes out.
Oh, okay.
And then I can tap either the sending or the receiving. Now remember, fiber has 2 pairs, right? There's a send pair and there's a send strand and a receive strand.
Okay, I didn't know that.
Yeah. So, but if you look inside this thing, it's actually a super, super simple device.
Oh, it just looks like it switches back on it.
Yeah, there's actually no electronics in a real fiber tap. It's actually easier to tap fiber once you know how it works. This is essentially a loop that goes from here to here. So it's just like, it's nothing. And then they slightly bend. I don't know if Alex can get in on this. They slightly bend that fiber just so it deflects enough of the light outside of the cladding that it can be picked up by another strand of fiber, which goes to this green one.
Oh, that's crazy.
So you're just siphoning off a couple of those photons.
So you're splitting the actual fiber and getting just a little bit of the light coming off of it?
Yep,
that's
crazy.
Crazy.
That's all it is.
Wow.
And the nice thing about this is it is absolute zero latency. There is no equipment in here to slow it down. They don't have to forward the packets. They don't have to worry about whether or not they're degrading the signal.
Is it pretty affordable too? I mean, there's not much to it. Oh.
Did this?
How much is that?
This module's about $1,000.
What? There's no electronics in it.
And actually, NetOptics, I'm really sorry I opened up your module.
But
I wasn't supposed to do that.
Oh, because it was like a secret magic sauce in there?
No, it's just no.
You're not supposed to do that. But man,
but you know what? I do it for you.
$1,000?
About $1,000.
Wow. Okay.
But remember, these are high-end devices. The thing is, this is $1,000, but I actually have done it in my lab, just using a fiber splitter and an patching kit. Because
and then you tape them together?
Yeah, so what you do is you scrape off some of the cladding, and then you put it close enough to another pair of fiber.
Yeah.
And when you start to get a little bit of light, just enough that you can register it on the tapping computer, you epoxy the whole thing down. And it's a mess because
it's not as clean as that.
It's so not clean. You can do it, and that probably cost me about $5.
That sounds like it would do a lot of trial and error, though.
It's a huge amount of trial and error, and you actually do have to know what you're doing.
Because cutting fiber.
Well, believe it or not, with the fiber strands that I work with, if you push it against your skin, it will go through your finger. Ugh. It's really, really sharp.
Right. Well, and then I mean, we've had fiber going to the computers, the edit machines here and stuff, and Alex always tells me don't touch the end of the cable.
Yeah.
Which I do all
anyway,
the time.
Right.
Yeah.
I've seen you downstairs like.
There's lights coming out of this.
And you wonder why the sand doesn't work sometimes.
It had dust on it.
Yeah. This one is expensive because this this one actually is the 10 gigabit version, so that's why it's crazy expensive.
Okay.
You can also find 1 gigabit versions of this for quite a bit less, but I would probably make my own.
Make your own,
if I didn't have a ready supply of these, because NetOptics may have trusted me with some product.
Wow. Okay. So yeah, there is a way to tap your fiber, and there's an expensive way, and then there's the do-it-yourself way that could be time-consuming, but it exists.
What I tell people, if you want to practice, there's a super easy way to do it.
Play with piano wire.
Put needles in your
right.
No, what you want to do is, the toss link, the optical out of a lot of devices.
Yeah.
Well, that's just an LED light, so it's safe. It's not going to hurt anybody.
Yeah.
And you can practice your technique. Scrape off the cladding so you get enough of the light coming out of the side.
Right.
Get another toss link cable, snip it, and try to get it close enough so that you actually start getting a signal on a second device.
It seems so strange that would work.
It seems really strange that it will work, and the first time it happens, you're like, no, wait, what?
You feel like
that's not possible.
I am the light bender.
I control the light.
Yeah, exactly.
So yeah, try it out, and that's super cheap, and it's really easy to do, and those Toslink cables are not expensive, and they're not going to hurt you, and everyone probably has an optical device.
Okay, cool. Yeah, I had no idea that you could do that. That's cool.
There you go.
Good question.
Let's go to the second question. This is something that popped up after our episode last week.
This is an ongoing discussion we've had, I'd say, during the whole course of building the PC.
Yeah, it always pops up in the chat room. Did you try hybrid? Did you try hybrid?
Hybrid.
Yo, hey bro, do you even hybrid?
Hey, I don't know if you heard about this. It's called hybrid drives.
Hybrid.
Check it out.
And so we want to give them their due. We kind of poo-pooed hybrid drives. I essentially said, unless you've got a single bay laptop, I wouldn't use it.
Right, because it's a compromise.
It's a compromise.
Not as good. Not as cheap as just a spinning platter, and not as fast as just an SSD. Right?
Yeah, so not as fast as a spinning platter. More expensive than not as fast as an SSD.
The first thing.
You know what I'm trying to say.
Yes.
It's more expensive than one.
Than a regular hard drive.
Slower than the other.
And slower than an SSD.
Thank you. My words, they do not work.
That's okay.
But no, seriously, hybrids are great.
Right.
I've been using them a lot. In fact, I've got a Seagate Momentous. This was one of the first ones that they released. In fact, this might be the first one they released.
They feel like a stopgap between when SSDs were super expensive, which the price just continues to come down.
When these first came out, like 2.5 years ago or so, they were actually great for what they were because they gave you better than hard drive speeds, but they didn't cost the ridiculous amount of money that an SSD would cost you. For example, when the very first one that I ever tested, the first SSD, this was a Samsung 470 series SSD. Nice device, very fast. Did 255 megabits per second read, 250 write. But this thing would cost you like $300 and some versus at the time there was this Seagate Momentous XT hybrid drive, which would cost you about $110, $120.
And you see a pretty decent performance gain, right?
Yeah, decent performance gain. It was maybe half to 60% of what the SSD could give you, but it was 4 times the capacity and it was 1/3 the price. So it totally made sense, especially if you had a 1-bay laptop drive. Now, I think maybe we should talk a little bit about what hybrid technology actually is, because there's a lot of misunderstanding about what it is and is not. So when we talk about a hybrid drive, there's actually 2 different types of technology that people associate with hybrid. Both of them center around this idea of combining spinning storage
with a flash memory.
NAND, solid state memory, very fast NAND memory. Now, in one case, you have this. So this is called an SSHD. This is a solid state hybrid drive. And in a single package, you've got the spinning drive and then you've got the memory that acts as sort of, the super fast cache. In this case, there's 8 gigabytes. Some drives
SSD.
Some drives have 4 gigabytes. Some drives have 16 gigabytes. So there was one that was rumored to have 32 gigabytes. I have not yet seen it. But to the outside computer, it just looks like a drive. It's a single device, which is kind of cool because then it's OS agnostic. You can use this on Linux. You can use this Mac OS 10. You can use this on Windows. All it knows is it sees a hard drive, and that hard drive seems to be pretty fast. There's another way to do this, and that is to combine something like this. This is just a standard rotating hard drive with something like this.
What's that?
This is an mSATA SSD. If you go to the overhead, you can see this, Alex. So the idea is this little device here, this is actually an SSD.
What?
Yep, that's an mSATA
to have, it has 24 gigabytes on it.
Yeah, this is a 24 gigabyte SSD. And this plugs into the motherboard. This plugs into the motherboard. So you have 2 individual devices that you actually
together.
They're working together, but the OS can see both of them. But it knows I'm using that smaller SSD to cache the hard drive.
Wow, I didn't know that existed.
That exists, like Apple's Fusion Drive, that's what it is.
Really? Okay.
And it's kind of popular just because you can typically get a whole lot more SSD. Like you can get these in pretty decent sizes. Which means the more cache you have, the more
faster, the more performance you'll get out of it.
Yeah, because the way SSDs, hybrid drives work, SSHDs, if the data that you're looking for is in that cache, that 4, 8, 16 gigabytes of cache,
then it'll be accessed really quickly.
Access as fast as an SSD.
But if it's not, then it has to go to the rotating platter to retrieve the information, and that's where you lose that performance.
So they do a pretty good job of optimizing what's in there. They look at not the files, but the data blocks that get loaded the most. So it's smart.
So it prioritizes the things that get loaded a lot, or or things that would typically need to be loaded faster.
Exactly, like operating system files that get called on a whole heck of a lot. So when you're accessing the flash part of the drive of the SSHD, it is crazy fast. It's ridiculously fast, and it is much less expensive. Well, somewhat less expensive than a straight up SSD drive. But the problem is, once that cache runs out, you go back to the drive, and it's
just like you're using a regular hard drive.
Which is not great. Now, there were people in the room who were saying, but Padre, you don't understand. And actually, let's go ahead and read the question. Alex, if you go ahead and go to that link. So we've got this from San Dunham, and I respect him. He actually made a really good point here, which is a 240 gigabyte SSD is roughly $125. Add on a terabyte of spinning drive to that for about $70, and you're sitting at nearly $200 for that configuration. By contrast, you can pick up a 1 terabyte 3.5-inch hybrid drive for about $105. Double the cost doesn't seem like a tiny bit more expensive, which is true. SSD prices are dropping, but they're not even close to competitive with spinning drives yet. And for those of us that need the space, hybrids are a valid option, even in a desktop. Now, this is where I disagree. If you've got the desktop, and if you've got an extra slot, I think you're crazy to go with a hybrid drive. And let me explain it. A fast hybrid drive, so like the latest version of the Seagate Momentus that includes 16 gigabytes of cache, that will get you about 110 megabytes per second of read, probably about 80 megabytes per second of write, which is decent. Right?
Yeah. That's what I'm used to.
Which is what you're used to. But go ahead and take something like a modern SSD like this. This is the Kingston KC300s that I like so much. This will do about 520 megabytes per second read and about 500 megabytes per second write. So it's not just a little faster.
It's like...
It destroys it.
It's like a
dances on its grave.
A prop airplane versus a jet.
Exactly. So I mean, you're not just talking about a little speed difference. You're talking about a huge speed difference.
Jump, yeah.
Now that didn't matter when we were dealing with these kinds of drives, when we had these old, like the 470s, because these would run at 200 plus megabytes per second, and even then the system itself wasn't really fast enough to take advantage of that.
Right, because you have to have the motherboard hardware and everything to be able to even transfer speeds like that.
But if you've got a lot of storage, it normally means you're probably doing something pretty serious with your computer, which means you've got a decent CPU, a decent motherboard, a decent GPU, and you starve it if you're not feeding it enough storage bandwidth. Right.
Okay.
And so you're talking about crazy slow, like 1/4 the speed, but the cost isn't that great. Let's take a 4 terabyte setup. In my ideal 4 terabyte setup, I would go with an inexpensive SSD. Which
how big of an SSD?
Probably like a 120 gigabytes.
Okay. Yeah.
Okay. Yeah, that's like the low price. I would actually go 240, but we're talking about cost now.
Okay.
So a 120 gigabyte SSD, you can find those for about $60. That will hit about 400 megabytes per second read, 400 megabytes per second write.
That's quick.
Yeah. You can find a 4 terabyte hard drive for about $130. Which, you know, that's a lot of space.
That's a ton of space.
Yes, it's $170 for the two of them. Now, a 4 terabyte SSHD, that's the hybrid one with 8 gigabytes of cache on it, will cost you $170. Which means if you look at it, we're sacrificing 80% of our performance for about $20.
Yeah, then.
That just doesn't make sense.
No.
It really doesn't make sense. And even if I was using my single bay laptop, I would still be reluctant. I mean, I gave that as one of the reasons why you would use it, but I'd be reluctant if I had a USB 3 or a Thunderbolt port, because both of those interfaces are actually faster than a hard drive.
Right.
So I would get the crazy fast SSD in the laptop and then plug in external storage for my lots of storage.
Right. And typically when you have that much storage, maybe like large video files or stuff that doesn't necessarily need to be loaded up quick, like an OS.
Right. So the long answer is, actually the short answer to the long answer is there a place for hybrid drives? I think so. I think they're really good tech, and I think a lot of people bring up a lot of really good points about when you would use it.
But for the cost versus performance, it's not.
It's really not. I mean, we talked about 20% or actually 11% increase of cost for an 80% decrease of performance. But if you looked at it in the cost of the entire system, like remember that Toshiba W50 that we played with, you're talking about a 59% performance penalty for like a 3% increase in cost?
Right.
No, don't do that. No.
The numbers just don't work. You've crunched the numbers, and it's not.
You've crunched the numbers. You can't crunch them a whole lot more than we already have. They're crunchy, man.
Okay.
Yeah.
Well, at least now I have a better understanding of how hybrid drives work. Like, I understood there was an SSD and a spinning drive inside of them, but now it's a little bit more clear. But it's still, once you've had an SSD,
it's hard going back. It's really hard.
They are more expensive, but once you've used one, it's hard to go back.
And use it the way that both of us use it, which is we've got the SSD and then we've got the monster drive.
Yes.
When we're doing a video editing project, you move it onto the SSD, and when you're done, you move it off.
Right. Yeah. At home, I have my my 3 terabyte drive, but on my laptop, I have like the 256 really fast SSD, and I don't really have a lot of big files on my laptop. I just save that stuff to the big hard drive.
Right. Right. So folks, again, I don't want this. This is not in your face.
No, there's a place for everything.
There's a place for everything. And yes, at some point, how about this? We're going to promise you we're going to do a comparison between a rotating drive, a hybrid drive, and an SSD, just so you can see for yourself the kind of performance benefits that you'd get from that particular technology.
Yeah, do like a price versus the capacity versus the performance.
Right, and we'll do both the integrated SSHD and the hybrid dual drive system. We'll do it all because, well, you deserve that information.
Hey, the nice thing is there's a lot of choices out there, and it really probably comes down to what kind of PC you want to build. You know, if you're doing a gaming PC, you're already spending about $1,000. You probably want an SSD in it. If you're just gonna have like a PC that, like a kit you were talking about that you were building for like somebody's first computer, get a hybrid drive. You know, because it's not gonna be as big of a deal for them. So.
Yeah, folks, it's all about giving you the knowledge. By the way, speaking of knowledge, did you know that there's a place online where you can get knowledge to dump into your knowledge hole?
Yes. Well, what I like to do is my knowledge hole has been filled to a certain extent, but I want to refine, I want to level it off.
So, you've got a couple of peaks and valleys.
Exactly.
You want to fill in the holes. You want to kind of make
it's more of like a knowledge pothole, on the knowledge freeway.
It's more of a knowledge sinkhole, is what you're saying.
I have a lot of those.
Okay.
But I use Lynda.
Lynda.com. That's right. Lynda.com is the place to go on the internet when you need to fill in your knowledge hole.
Well, we're switching over to Premiere, and so I've been doing a couple of outside projects to kind of practice it, and some of the things that I do with Final Cut seem really easy on Final Cut, and I don't know how to do it in Premiere, but fortunately, Lynda has all that stuff stacked out.
Exactly, and I think that's what makes Lynda so valuable, in that it's both a place to learn for the first time. Like, for example, if you wanted to learn about GoPros and using GoPros in quadcopters, Lynda is a great place to go because they've got courses that will take you from step 1 to step 8. They'll show you how you should mount it, what kind of footage you're going to get, how you should edit it. And that's really the strength of that sort of beginner knowledge.
Yeah.
But they also do this indexing, this wonderful indexing, which allows me to pull up an answer. Let's say, well, I've been using Premiere for 12 years.
Right,
but
I'm not a newbie, but there's a few things that I don't remember how to do, so I brush up on it.
And that's what Lynda lets you do. Lets you go to what you need at the time, be it a beginning lesson, an intermediate lesson, or an expert lesson at lynda.com. That thing. Now, lynda.com is your one-stop shop for knowledge. It's a repository for all things awesome. They're an easy and affordable way to help you learn. You can instantly stream thousands of courses created by experts on software, web development, graphic design, and more. They work directly with industry experts and software companies to provide you timely training, often on the same day. You get the new releases, the new versions, so that you'll always stay to date with the latest and the greatest of the tools that you have to use each and every single day. Now, all their courses are produced at the highest quality, not like the homemade videos on YouTube, which I love. I mean, that's where I come from. But sometimes you want to get all that bad lighting and the bad audio out of the way and just pay attention to the knowledge. I mean, we're all about the knowledge, folks, and sometimes you just want to concentrate on the things that are important to you. Now, their tools, as I mentioned, include those searchable transcripts so that you can use it as a reference when you need an answer to one little nagging problem that just doesn't seem to go away. So whether you're a beginner or advanced, they have a course for your experience level. You get to learn while you're on the go with the lynda.com app for the iPhone, the iPad, or Android, and they have one low monthly price of $25, which gives you unlimited access to over 100,000 video tutorials. Now, premium members with an annual plan can download courses to their iPhone, their iPads, or their Androids and watch them offline. That gives you the ultimate reference tool. If you're out in the field and you don't have a connection, have those lessons downloaded to your device so you can recall them if you're field stripping a GoPro off of a quadcopter, or if you're in the field and you need to know more about the lessons you took on data management in a data center. It's all there if you become a premium member. Now, they have also got courses on iOS 8. So if you want to know all the new features, all the new tricks, and be up to date with the latest and greatest from Apple, they'll give you that. Or they'll give you simple Android development tools. Now, Monday productivity pointers, which I could probably use, and songwriting tips in Logic Pro. For any software that you rely on, lynda.com can help you stay current with all software updates and learn the ins and outs to be more efficient and productive. And we've got a special offer for you. You can access all the courses free for 7 days. That's right, completely free. Visit lynda.com/knowhow to try lynda.com free for 7 days. That's lynda.com/knowhow. And we thank Lynda for their support of Know-How.
Yeah, I mean, I'm really looking forward to using the quadcopter stuff that we're going to be doing.
We're going to crash that thing.
Looking up, yeah, we're totally going to crash it all the time. But at least I can feel assured I've looked up enough stuff on it to...
The crashing won't be from lack of knowledge. It will be from lack of skill.
Yeah, skill and experience. How are you going to get good at it unless you crash it a few times?
Right, we're going to crash it a couple of times. And actually, we're going to start talking about that when we come back. But first, your friend and mine.
Yeah, Aaron Newcomb, our Linux, our resident Linux expert, who is a nice guy, super smart, comes all the way up here and does these Linux tips for us. And for myself, who I grew up using Windows, and so I'm definitely a GUI guy, a graphical user interface kind of thing. The terminal has always been kind of a mystery for me. So Aaron came in, explained what terminal is, and gave us a few commands to help you get by.
Hey everybody, Aaron Newcomb here again for another Linux tutorial. So hopefully you've been getting some useful information out of these. If you're a beginner or new to Linux, that's what we're shooting for here. So right now, just to recap, we've got our desktop set up. We've installed it. It's working great. We've installed some new software. So we know where everything is. We know where the browser is and all of that great stuff. So pretty much this is your standard desktop environment, and you should be able to play around with it and get familiar with it. But we need to do a little bit of a deeper dive before we go forward with any more tutorials. And the reason is because we need to talk about the terminal window or the terminal. This is typically represented by a little box down here. It might be on the taskbar, or it might actually be in the menu under accessories. That's where it usually is. Sometimes you can find it right over here, so it's really easy to find pretty much everywhere. And the reason it's easy to find is because it's so darn useful. So the very first thing you'll see is that you have usually your name and the name of the computer here presented to you, along with what's called the prompt. That's the little $sign here. And when you type, the words will go right next to the prompt. So if I type in a command like ls, that's where the words appear, and that's normal. In this case, let's do ls, and you can see that it prints out a listing of the files that I have in this current directory. So it's as simple as that. You type in the command, press enter. Really simple stuff here, right? Now, some of the shortcuts and things that you'll want to know about the terminal as you get started. If you use the up arrow on your keyboard, that will cycle through the list of commands that you've used most recently. Terminals keep a command history, obviously for the very simple reason is that you reuse commands a lot. You can see there I mistyped a command. So all of these commands that you've used previously are in the history. That's a good thing to know because it makes it really simple to access those commands, so you don't have to type them in from scratch when you want to retype a command that you've used previously. Another really useful command that took me a while to find out is that if you press Control-R, so you hold down Control and press R, that'll bring up this thing called reverse I search. Basically, all you need to do here is start typing the first part of the command that you want to search for. You're searching through your command history. So if I type apt, A-P-T, you'll see that it'll pull up whatever the most recent or closest match is from my recent history. So in this case, I haven't had an apt, but I have had an A in a command, and so it pulled that up. Then you can backspace and type in a different command, maybe ls, and you can see that it pulls up that command. And then what you can do is you can continue to press Control-R, and it will cycle through the commands that you've typed. that have ls in them. And it'll just do this in a circular fashion until it gets back to the beginning. There's no more ls's there. So once you've gotten the command you want, you can hit enter, and it'll run that command. So that's really good to know. The other really good thing to know is that as you're typing a command, sometimes you may not remember the full name of the command, and sometimes you may not know how to spell a certain command. Sometimes things are a little wonky in Linux. So, for example, if I do apt, let's say I don't remember the command that I want to use. It's apt something. You can hit apt, and then you can hit tab twice, and it will pull up a list of all of the commands that it knows about that start with apt. So this is really helpful as you're getting used to the terminal. These three things can be really helpful in getting you set up and getting you going right away. All right, let's talk about some of the basic commands you're going to need to know in order to feel comfortable on the command line. The first one, and maybe the most important one, is a command called man, M-A-N. And why this is important is because it stands for manual, and this was actually something that was built in early on in the early days of Unix, before Linux. This was developed by people like Dennis Ritchie and some of the very first people to develop Unix, because they knew that they needed a instruction manual for the various programs. They needed to document the instructions for various programs that they were developing, and they didn't have a way to do this. So they came up with a way, and it's called manual, or man. The command is called man, and it stands for manual. So if you want to know what a command does, in this case, let's start with ls. We've used that one before, and I'm going to talk about this in a minute. But if you wanted to know what the command ls does, then you would type in man space ls. That's going to bring up a man page. This is what the man page looks like. It's going to give you a ton of information on how to use the command, what all the options are, how you structure the command on the command line. In this case, it's ls space, and then the options space, and then optionally you can also include a name of a file to get information about. So that tells you how to structure the command on the command line. It tells you what all the switches does. If you press space, it'll page down, and you can find all sorts of information about this command and what all the options are. And a lot of these commands, just like ls, they have a ton of options. So there's no way we can cover all those options in a tutorial like this. So it's really helpful to know that you always have the man page at your disposal to go look up more information about these commands. So that's the first one. The second one we've already talked about here a little bit is ls. That is a listing of a directory. It's a directory listing or a file system listing. So as we did before, we typed ls and pressed enter, and that gave me a basic listing of all the files I have in the directory where I am. How do I know what directory I'm in? Well, there's a command for that. It's called pwd. Pwd will tell me where I'm at in the file system, logically where I'm at in the file system. And you can see I'm in the directory home a nukem. So that is my home directory. And when I typed ls, it gave me the listing of all of those things that are in my home directory. Now, if I type in ls minus L, that's going to give me a little bit more verbose readout of the things that are in my home directory. Here, there's lots of things listed, all the properties about my files. In this case, they're all directories, but lots of things about those files. And we won't go into the details on that, but it's good to know that option is there. Now, you can also do an ls on some other location, ls / let's say etc. This is where a lot of the configuration files are stored. And you can see there's a lot more information in there, but it doesn't really matter where you are on the system. You can do ls and then type in the location where you want to get that listing from. So if you're familiar with Windows, back in the old days, there was a command called dir for directory listing, and that is a similar command to ls, although as with everything on Linux, ls is much more capable than the directory command was on Windows. All right, let's talk about some more. So what if I want to change my directory or change where I'm at? We mentioned before pwd will tell you where you're at. What if I want to go to a different place in the file system? What if I wanted to go to the etc directory because I want to do some things there? So that command you would use is cd for change directory. And we'll just type in /Etsy. And now I am in Etsy, and you can see on my prompt down here, it actually tells me where I'm at. So now I'm in /Etsy, and if I ever forget, I can look at that, or again, I can just type in pwd, and it'll tell me exactly where I'm at. So that's how the change directory command works. If you want to go back to your home directory, here's another cool shortcut I will teach you. You can do cd space tilde /. Now, cd space tilde represents your home directory. It's just a little shortcut. Type that in, and now I am back in my home directory. Okay, so let's keep going. Another useful thing to know that you're going to need to know, especially when you're working in the command line, is how to copy and paste, how to move things around based on the where you're at. So I'm going to create a file called cool file. Don't worry about that touch command for now. But if I do an ls, you'll see that I have a file here in my directory now called cool file. That basically just creates an empty file with nothing in it, that touch command. Let's say I wanted to make a copy of that file and call it something different. I could use the cp command, cp, and then I could type in what my the file I want to copy. In this case, it's cool file. Now notice I'm just going to start typing the first little bit and then hit tab, and that completes based on what's there. So cp cool file, and then I'm going to call it not cool file. I don't know why, but that's what I'm going to type. So this is going to copy the file cool file into a new file called not cool file. And when I hit enter, it has done that, and I can do an ls, and you'll see I have two files now, cool file and not cool file. Pretty cool, or not cool, as the case may be. That's how the cp command works. Another one you're going to need to know is how to move a file from one place to another. So not just make a copy, but actually move it. So that is done with the command mv for move. All makes sense so far, right? cp for copy, mv for move. We're going to have the same structure. So we're going to move, let's see, in this case, we'll move not cool file, and we're going to move that into the Etsy directory. So I do //Etsy. A little different than Windows there. We use / to for the separations between the various directories, and not a backslash as Windows uses. So we're going to move that into Etsy. So I'm going to hit enter. Uh-oh, can't do it. The reason why is because that Etsy directory is protected because it is like I said, there's a lot of configuration files in there, and we are not root. So how do we overcome that issue? Well, there's a command that you'll see in a lot of tutorials called sudo, S-U-D-O, and that gives you special permissions to act as the root user. In the Windows world, you'd call this the administrator account. But in Linux, we don't have an administrator, but we do have a root user that has special permissions to do basically anything on the system. So you can really screw things up when you're the root user. So you got to be really careful. In this case, we're just moving an empty file around. We know it's not going to hurt anything, at least we hope not. So in this case, we'll do sudo, and then we can use that same command. Now, I could type the whole command out, or, as I mentioned before, we could just hit the up arrow. That's going to give us the command that we had. And I will just go to the beginning and do sudo and hit enter, and it'll ask for your password. Make sure that you're not a nefarious user, and hopefully it's moved that file, not cool file, where we wanted it to go. So let's do an ls where we're at. Yep, I don't see the not cool file anymore. Now let's do an ls of /Etsy. And not cool file is right there. There it is. So it moved it over there. So I know we're arming you with a lot of information today, but these are just some really basic things that you need to know to get going.
Cool. Well, thanks for that, Aaron. And Padre, what would you say you took away from that?
I am root.
I'm so glad I let you do that. But no, again, thanks to Aaron. But when he came in and he showed me some of that stuff, it gave me enough of a foundation that I was able to, for once, extract a package that I had downloaded. So,
right.
So I feel like I'm gradually moving along, and those are just some of the basics. And he mentioned once you get the hang of it, you do feel like you're superhuman going through just doing command line stuff.
I think both of us are in the same place with Linux, where we both use it. We both have it on several of our boxes.
Yeah, we've played with it.
But both of us do the whole thing where, like, if we mess something up, it's easy for us to say, oh, it'll take me 20 minutes to reinstall and just put all the packages back, rather than figure out what I just screwed up.
Right, when I was installing Ubuntu on my virtual machine on my laptop, I screwed up the resolution, don't know how, and it was easier for me just to reinstall it, and then it fixed it.
But I mean, these are the lessons, especially the command line stuff. These are the lessons that will let you start poking around and saying, oh, that's where that setting is kept. That's what I have to do to fix this thing that I just messed up. That's what I have to do. Like, for example, anytime on the Raspberry, I got used to, whenever I was testing new network adapters, just install a new image of Raspberry rather than try to figure out what I have to change and what package I have to install. It's like, no, once you figure this out, you don't have to do that anymore.
And for a long time, like when I was doing the Raspberry Pi project where I was doing the game, the MAME machine, it's a lot of just going through forums and copying commands, but it wasn't like I had a full understanding of what all the commands meant. And having Aaron come in and explain some of this stuff, it's like, okay, like I understand the directory system a little bit better. I know how to navigate to certain files or where to go to find them and stuff. And
I'm with Dr.
What are you looking at?
Dr. Morbius is saying normal people shouldn't use Linux.
I don't think any normal people use Linux. I've met a lot of Linux people.
I think normal, actually, okay. So, but normal people can use Linux, and Linux is understandable. You just, you have to demystify a lot of it.
Yeah, and the fascinating thing about Linux is how deep you can dive. Like you can spend your entire life, it feels like, trying to understand Linux. But the more you understand, the cooler it is, and we're all about, knowing things, and bringing on experts who explain it to us.
Now, we're going to be going on to our segment now about flight, because we have to clear up a few things before we get into our quadcopter build.
I think I know about Flight, Padre.
Wait, okay. We're going to test your knowledge in a bit. But first, Alex came over during the break, and he showed us these
He's so excited about these.
If you like SSDs, you're going to love his new system that he and Russell have been working on, a brand new production system for TWiT. And it involves these carts that have these, is it 350?
240, I think they say on them?
4 of them are 240, one is 480.
240, 40, but they look 350 megabits per second read and write.
Yes.
Oh.
Yeah. So they're slower speed, but these are enterprise class, so they last a lot longer, which is what you need when you are regularly completely filling and then emptying out the SSDs.
They don't feel real. I don't know how to explain it, but this doesn't, it feels empty. Like this is...
You were saying how this looks like the cartridges from...
And from Ghostbusters. I know that's why Alex is excited about it.
I think that's the same idea, because they plug it into the ingestion system, and there's a little red light, and when the light turns green,
you know you're clean.
The card is clean.
Yeah.
So we got some Ghostbusters going on. We're actually going to give you a behind-the-scenes look, because I found the system that they're building is absolutely fascinating.
It is. It's kind of a one-of-a-kind thing.
It really is. Yeah, we're building something here that other people will duplicate at some point. But we're going to show you how we're using SSDs for every bit of content that will be flowing through the TWiT brickhouse.
And ironically, the 350 megabyte a second of the drive is the bottleneck of the transfer speed.
Bottleneck?
Yeah. So this now becomes the slow part, which is ridiculous. So now, if we used hybrid drives, we'd be here forever.
So we'll have our 10 gig Ethernet network for the transfer, but it's pulling off that drive, which is 350 megabytes a second.
I think I'm going to be playing around with that for a while.
Hey, where'd those drives go?
All right, cool. All right, sweet. All right, let's go ahead and talk a little bit about flight. Brian, you mentioned that you learned everything you needed to know about flight and how things work and why they work and why planes stay in the air. What did you learn?
I learned, well, I think I learned, air going over the top of the wing is moving at a... Now I'm blanking.
It's Bernoulli's principle, right?
Bernoulli's principle. But is it faster or...
It's faster over the top.
Over the top and slower underneath, which creates lift.
Which happens because as the wing moves through a volume of air, it splits it, right?
Right.
And what happens to those two volumes that it's created?
They Wait.
They'd like join up at the end.
Right, yeah, they come together at the end.
Exactly.
Like,
this is what a lot of school kids were taught about flight.
I've seen like all the little graphics. There's usually like the little circles go underneath and the X's go over the top and they connect at the bottom.
Yeah, so if you take a look at a wing like, exactly, there we go. But see, this is actually showing us something that we shouldn't be seeing. In a bit, they're going to break up this airflow and do spurts of smoke over this wing so you can see exactly what's been happening. As you said, most kids were taught that as a wing goes through the air, it divides the volume so that you've got air going over the top and air going over the bottom. And they have to get to the end of the wing, the trailing edge of the wing at the same time, which means, of course, that the volume on the top is going faster than the volume over the bottom because it has more to travel. But if you look at this, that's totally not true. That doesn't happen at all. The volume they get split.
The angle of attack on the front of the wing splits the air, forcing it underneath, which then pushes it up.
Well, it forces a volume underneath and a volume over the top, but notice how much faster the volume over the top gets to the trailing edge of the wing. They do not rejoin at the trailing edge of the wing.
Makes sense, yeah.
Right.
Okay.
And so, you know, Bernoulli's principle is still, it's not disproving Bernoulli's principle. No. Bernoulli's principle is part of flight.
It's just kind of redefining the way you think about lift.
Exactly. Because most of us have been taught that Bernoulli's principle is the thing that causes lift. Because the air is going faster over the top of the wing, it creates lower pressure, and that lower pressure sucks the wing up, therefore sucks the plane up into the air.
Yeah.
Sounds good.
It helps me visualize
Helps
it.
you visualize,
that's for sure.
but it's not really what's happening.
Explain it to my Padre. Why are these metal birds flying around all the time?
These metal birds are flying around because of Newton's second and third laws of motion.
So for every action, there's an opposite and equal reaction?
Exactly. That's one of them. So Newton's second law of motion tells us that for every force that's being exerted, F equals m times a. Force equals mass times acceleration. So that the force being exerted depends on how much mass and how much you're accelerating it. Newton's third law is the one that tells us that for every motion, there's an equal and opposite
That's
reaction.
The one I know,
remotion, action, motion.
Something.
You got me. So second and third laws are actually what keeps a plane up in the air. As a plane is going through, as a wing is dividing that volume of air, yes, there's lower pressure on the top, but the primary force of lift is the air that you're redirecting. As you direct volumes of air down, it's going to create a force
pushes you up.
Right, and the faster you do that, and the more air you push, the more force you get up.
Right. The more force you'll be exerting.
Right.
Yeah.
Now the end result is that it will create a high pressure area below the wing and a low pressure area above the wing. So Bernoulli's principle is still valid. But for kids who were taught to believe that that's the only thing holding an airplane in the sky, a wing in the sky, it's just not true.
Yeah.
It's just not true. Right. And the reason why we're telling you this now is because we're going to need to know this as we move into designing our quadcopter.
Right.
On this particular plane, if you go and go to the overhead, Alex, these control surfaces here, no, that's the propeller. This allows me to direct air in different directions. So I can make it go up and down on the back of the wing, which will force the plane. It will change.
So that'll make it go up or down.
Right, and this will make it go left and right. Right, so all I'm doing is I'm deflecting air, and as I'm deflecting air, that volume gets deflected this way, and the plane will turn this way. Or if I go that way, or if I do this so that it's down, the tail gets pushed up. If it's up, the plane gets pushed down.
Right.
So the reason why I'm showing you this is think about a quadcopter. So let's take a look at this thing.
Quadcopter doesn't have wings. How does it turn?
Not only does a quadcopter not have wings, but it doesn't have a rudder. It doesn't have ailerons. All it has are these four propellers.
Right.
Now, it's important to know about lift because these four propellers, if you go ahead and pick up those big propellers there, it's actually creating lift. It's holding this quadcopter up because of Newton's second and third law. The shape, the angle of attack of those propellers are what allow it to generate thrust. Now, what we're going to learn in the next episode of Know-How is we're going to learn exactly how it works on a quadcopter, how it uses the varying thrust and power that goes to each of these propellers in order to create the directional force that it needs to be able to fly properly.
Right, because it's all software.
It's all software because unlike a plane where if I push my throttle this way and it pushes a servo this way and there's a direct linkage, In a quadcopter, it's all fly-by-wire.
Right.
When I give it an input, the computer on board has to say, well, he wants to go forward, or he wants to bank left, or he wants to bank right, and it has to adjust the thrust to each propeller accordingly.
Which is pretty fascinating considering how small these are getting.
Right.
And how maneuverable they are. And yeah, these are set up like a helicopter propeller, but
What was that?
Helicopter?
Go, what's it?
What?
Oh.
Sorry. My finger. But unlike a helicopter, which would have a propeller on the back that is also
yeah, the tail rotor. So
tail rotor, which helps it do side-to-side stuff.
Right.
This doesn't have it.
Because that's, well, we're going to talk about that, but that's rotational energy. So if my propeller, this is also Newton's third law. If the propeller is moving this way, the body of the craft wants to move the opposite direction. And so on a helicopter, it's got that tail rotor to cancel out that force, right?
Yeah.
There's no tail rotor here, so now we have to figure out how this works.
That is so cool.
It's very cool. Now, we're going to be doing this over the next 12 or so weeks. We're not going to go complete. We're going to put a couple of breaks in there because I know people are going to get tired of quadcopters. And we're also making sure that there's plenty of other material that's going to go into Gadget. But into know-how. But what we want to do is we want to show you how you can go from basic frames and motors and remote controls into building your own quadcopter. We're going to give you a couple of different classes that you can build, a couple of different costs that you can build, everything down from I think $50 is the cheapest, all the way up to like $3,000, depending on what you want to build and what you want it to be able to do. But starting next week, it's quadcopter, baby.
Yeah.
Excited?
I'm very excited. The more I learn about how they work, the more I want to build one.
Yeah. We are going to give you a complete part list of everything that we've bought for...
Just like the lunchbox.
Just for the lunchbox, but we want to give it to you at the beginning because we know there's going to be a few of you who are going to want to buy some of your parts.
Play along.
And play along. So we'll make sure that you have that ahead of time. For the rest of you, just watch it because we're going to give you a couple of different options, including something like this, a super inexpensive way for you to learn how to fly a quadcopter before you decide whether or not you actually want to sink a lot of money into it.
Inexpensive and impressively, yeah. Like between you, Tony, and me, we have crashed that thing in the studio.
Everything.
Yeah, and it still goes. It's okay.
It's still. I mean,
it's not great.
Let's see.
But it obviously still flies.
It's not supposed to fly on an uneven surface like this, but oh yeah, it still goes.
Yeah.
So now we know that this has been a lot of material for this episode of Know How. Everything from the feedback to Aaron's segment on Linux to our quick introduction on flight and the project list for the quadcopter. But we don't want to make you have to watch the same episode over and over again. Instead, what do?
We will have them curated on twit.tv/KH.
Yeah, go there for our show notes. And as long as you're checking out our show notes, why not download some of the episodes that will help you with projects? In fact, I'd say go ahead and look at Project Lunchbox because a lot of those same principles are going to transfer over into building a quadcopter.
Yeah, that'll help you get started with the whole remote control world and everything like that. And yeah, don't forget to subscribe, download the HD version so you get all that high definition goodness.
We do a lot of notes.
We do a lot of notes, but we have a lot of good information.
Yeah. Don't forget that you can also find us on Google+. Just go ahead and go to Google+ and look for the Know How group. It's 7,300 or 7,600 members strong. There's a lot of people
it's getting close to 8.
Yeah, close to 8,000.
There's a lot of good stuff being posted in there, a lot of good questions being asked, and before we were able to answer them, a lot of people hop in. So.
Yeah. It used to be that I'd have to jump in there every once in a while, but now
it's its own community now.
It really is.
Of just people who like building stuff.
They like the knowledge in the whole. Also, you can find us on the Twitters. You can find me at twitter.com/PadreSJ. That's at PadreSJ.
And I'm at cranky_hippo.
And don't forget our super TD, the man who's letting us take home these carts.
What carts? I only saw there was only 2 out here, right?
I know. Wow. Yeah. Go figure. But that's right. Alex Gumpel, ANELF3 on Twitter. Follow him to find out what's going on behind the control desk, folks. Know How is a crazy place, and yeah, it's
what a
jerk.
Alex.
What a jerk. Until next time, I'm Father Robert Ballasare.
And I'm Brian Burnett.
And remember, now that you know,
go do it.
Yeah.